Example 2. Identify the values of the variables for which each expression is defined, then expand, then expand and simplify. A. 7 plus 2 root b times 3 minus 5 root b. Now this is really easy. We know that b must be greater than or equal to 0 because the number underneath a radical, or the radicand, cannot be negative. And now we are going to simplify just as we did with the radicals with simply numbers. We're going to use our happy little rainbows, and we are going to FOIL it out. So the first one here, we have 7 times 3, minus 7 times 5 root b, plus 2 root b times 3, minus 2 root b times 5 root b. So we're going to simplify this. 21 minus 35 root b plus 6 root b minus 10 root b squared. Interesting. So that equals 21 minus 29 root b minus 10 b. Now we would have to say the absolute value of b, except for in the beginning here we defined it as b has to be greater than 0. So we know that it's going to be greater than 0. So that means we don't have to worry about that value being negative. Let's do another one, shall we? B. 3 root x plus root y, 3 root x minus root y, there's a conjugate, minus root x plus 5 root y squared. Essentially, to simplify this, it would just be difference of the opposite of difference of squares. Actually, we would just square the first term minus the second term squared. Oh, my bad. This one says root 5. I meant root y. Yeah, because that wouldn't actually be the conjugate. So I'm going to do this the quick way here, and I'm going to say 9x. Oh wait, I forgot something. We have to say that x, both x and y, must be greater than or equal to 0, because if they are negative, these radicals cease to exist. 9x, so that's 3 root x squared, plus root y squared is just y. Cool, hey? That was easy. Otherwise I would have to like expand it out and FOIL it, but if you know that trick, that when you multiply it by the conjugate, you say the first term, okay, squared, minus the second term squared, and then minus this one right here. Now, this should be a trick that is in your toolkit. I am going to do this very quickly, and I hope that you'll join me in figuring out how to expand something like x plus 2 squared. Just using this guy here as an example, I would say that x plus 2 squared, I just know, is x squared plus 2x plus 4. The first term squared plus, oh, my bad, that was for x plus 1. This is x plus 4. So the first term squared plus 2 times this term plus this term squared. Let me just do it with 1 so we can see it even greater. Okay, x plus 1 squared, that equals x squared plus 2x plus 1. 1 squared, 1 times x times 2 is 2x, and then this one squared. So I'm just going to do that with this one here. Okay. If you want to have more worksheets and how to expand this type of a binomial, come and talk to me. Come and talk to me B block on Monday. But I'm just going to do this real quick. So we have root x squared, so that's x, plus 10 root x y, plus 25y. That's how quick that has to happen, okay? Or that's how quick this can happen if you put the time into figuring out how to expand a binomial in this way, how to square a binomial. So then I just need to carry through that negative to all terms. 9x minus y minus x minus 10 root xy minus 25y. 9x minus x is 8x minus y minus 25y is minus 26y, and then we have minus 10 root x y, and that's that. If we were to do this the long way, if we didn't know these tips and tricks, literally what you would need to do with this one is like make the happy little rainbows, and this one right here you would have to rewrite. Okay, so x, root of x plus 5 root y times root of x plus 5 root y, and then you would have to expand it like this again. Knowing that little tip and trick will really help you out in being able to expand these quickly.